Hey mathematicians, let's talk about what a ratio is. We're going to talk about how to write a ratio and the two different types of ratios that we'll be dealing with. Okay, so our first key point is that a ratio, which is pronounced ratio, not radio, which is how it looks. A ratio is a comparison of two different things. It's really important that you know what those two things are because they need to be separate. They can be of like a similar family, like two different colors or two different shoes, but they have to be different in some way. The second key point is that ratios can be written three different ways. This is really important. You can use whichever way you want, but you need to be able to recognize all three. The first way to write one is with the word to separating it. The second is with a colon, and that's that dot dot that usually starts like a list. And the third way is with a fraction bar. So let's use these blue and yellow circles on the side to model the ratios in three different ways. Another thing that's important about ratios is the order. So if I ask you for the ratio of blue to yellow, you have to write the number of blue first. So if I'm going to write it with the word 2, I might write 3 blue, I don't really know what they are, blue something, blue circles, 2 yellow. Additionally, you can also just write 3 to 2 if I've already told you the order of the ratio, like in the problem. So that's one way. Another way is with a colon. You could write 3 colon 2, and we'd read that as 3 to 2. And the third way is with a fraction bar. The first thing goes on top, 3 to 2. That's how we're reading it as a ratio. Not 3 halves, because that would be a fractional amount. This is really 3 blue for every 2 yellow. And that's an important part too, because it doesn't just have to be 3 and 2. A ratio can be scaled up and scaled down, and we'll talk about that more in other videos. Okay, there are 2 ways that we can think about ratios. We have 3 ways to write them, 2 ways to think about them. Ratios can be expressed as part-to-part or part-to-whole relationships. Let me show you what I mean by that. So we can say a part-to-part is saying, oh, there are 3 blue to every 2 yellow. I'm going to jump down to the bottom, blue to blank down here. A part-to-whole or part-to-total means that we are comparing one part of the ratio to the total number. So if I look at total number of colors, I have to add 3 blue plus 2 yellow. So that's really important, is we have to add all the items together before we can come up with a total. So blue to 5 colors, or 5 total colors, colored dots, however you want to call them. If we're talking about, let's say, comparing two things, boys to girls, then when we do, that's a part-to-part, one part's boys, one part's girls. If we talk about a part-to-whole, we can compare one of those parts, either boys or girls, to the total number of students. So you'd have to add them all up to find your total. We can compare cats to dogs. That's a part-to-part, cats, different from dogs. Or we can compare a part to whole and say, okay, cats plus dogs, how many animals is that? And you can do cats to total animals. So we can do blue to all the colors, all the students to girls. That's a whole to part ratio. They can go either way. Cats to all the animals. So it's really important to read your problem carefully so that you know if I'm asking for a part to part ratio or a part to whole. Another way to organize your work is with this little chart. You can see on the top we've got the part, we've got another part, and at the bottom the whole thing adds up to a whole. Let's look at one more example. Okay, so here's our example. There are 4 puppies for every 7 total animals. So I'm telling you the part that's puppies. I'm using the word total or whole. That's a really good hint that that's talking about all of them. And I'm actually in the question telling you what the other part is because I'm asking you how many kittens there are. So here's how I use that chart to help me. I draw it out for myself. I have my part whole. And I think, okay, so I know the part that's puppies. There are 4 puppies for every 7 animals. So that's 4 of these cute little puppies for every 7 total animals. Reading the whole question, I see that we're talking about puppies and kittens, so it must be that those are the total. So this is 7 total puppies and kittens together. Oops, there we go. So then I can think about, well, how many of these are actually cats or kittens? The parts added together have to equal the total. So you can use the inverse of adding and say 7 minus 4 puppies. That must be 3 cats for every 4 puppies. So in using a part to whole relationship or a part to part relationship, you should be able to find that missing third piece of your ratio.